Welcome to Basic Programming in Ruby (PD) for senior students in Victoria. Ruby was designed and developed in mid-1990s by Yukihiro Matsumoto in Japan. It is a robust, dynamically typed, and object-oriented language. These include the popular booking site Airbnb and the TV streaming service Hulu. Other applications include GitHub, Goodreads, and the calorie tracking application MyFitnessPal. We are going to start off with the basics like downloading and installing Ruby, getting Ruby set up with Item text editor, and executing the first Ruby program. We are going to look at some of the basic things like variables, different types of data, storing data, string, math, get user input, build a MATLAB game, array, learn if statement, and while loop, do while loop, for loop. We are going to build a couple of different games. So not only are we going to be learning Ruby, but I'm going to be showing you how to apply it in a bunch of different situations. In this course, I'm going to cover just about every major topic in Ruby. So by the end of the course, you should have a pretty solid understanding of what this language is about, what it can do, and what you can do with it. Installing Ruby on Windows is actually a pretty easy process. Essentially, all we have to do is to use Ruby installer that we can download from Ruby's official website, and it will basically walk us through all the installation instructions. I'm going to install the latest version of the current time, which is Ruby 3.0.2. Be make sure that you read Ruby's license before installation. Ways of installing Ruby. We have several tools on each major platform to install Ruby. On Linux, Unix, you can use the package management system of your distribution on third-party tools. On macOS machines, you can use third-party tools. On Windows machines, you can use Ruby installer. Once you install the Ruby, you accept the license and click Next. You specify the path to install Ruby and click Install. The installation is on process. After installation, you click Finish. You jump into the terminal windows. You have options 1, 2, and 3 to install. If you're not sure, just press Enter. Now, we install Item text editor. One of the cool things about Ruby is you can basically write Ruby code in any text editor you want. After installing Item, we are going to look at how we can write our first Ruby program. The installation will take a while to complete. In order to be running Ruby programs on Item, we're actually going to have to install one thing, which is a package. On the settings page, we want to search for a program called item-runner. And essentially, what this plugin is going to allow us to do is going to allow us to run our Ruby scripts or our Ruby programs. From the menu of Item, I add a project folder to create a working folder, then create a new file, and I'm just going to call this ruby.rb. So whenever we're creating a Ruby file, we want to use the .rb extension, telling our computer if this is going to be a Ruby program. And now we have our first Ruby file up and running. So what I want to do now is just write a simple line of Ruby code. We'll test it out. We'll make it sure everything's working. Over here, I'm just typing hello world. Run the program by pressing alternate R. On the item text editor, we can see on the top here with the hello world in green, and the bottom one is the outcome of the program. Variables. In Ruby, we are going to be dealing with a lot of different data, and we have a special container where we can store data values called variables. We want to use that piece of data or access it or modify it. We can just refer to its variable container. Let's look at the example on the left side here. We want to print all these lines. There was a lady named Kathy. She was 60 years old. She really liked the name Kathy, but she didn't like being 60. The outcome of the program we can see here on the right side. Now, when I want to change the character's name and the character's age, I have to manually go into my program, into the story, and modify each value. So every place where the character's name is mentioned, I have to update it to the new name. Every place where the character's age is mentioned, I have to go in and update it. And this is kind of problem if we have 100 or 1000 lines of code. We need to go through all these lines to update the values. This is a situation where we have two pieces of data, the character's names and the character's age, and we are going to try to keep track of them. So I'm going to create two variables, character name and character age. Whenever I want to update the story, I just go ahead and change the values of these variables. How can we name variables? We have some rules for variable names. It's better to have a variable name that's long and descriptive than one that's just a single letter or confusing. Even though it might take more time to type, variable stores and keeps track of all different pieces of information we encounter. So that should be clear and understandable. Data types. Essentially, we have three different data types: text, numbers, and Boolean values. The text, often called strings or characters, including names, addresses, the text on this page, etc. Numbers, money amounts, dates, distances, etc. And in number, we have two different types of number: integers, which are whole numbers, and floats or decimal numbers. For Boolean values, we have also called true-false values. If someone is an Amazon Prime number, if someone is in military, or if a TV show has been cancelled, this type of data may be less intuitive to a new programmer. But trust me, you'll learn to love true-false value. Let's have a look at those four values here. We make four variables with different data type. Name, I assign the string ND to the name, the value 30 to H, and the decimal number 6.1 to GBA, and the Boolean values false to is told. And then we use put commands to print all these values on the screen. Your name is Andy. I am 30 years old. My GPA is 6.1. String. All characters in a string have specific indexes associated with them. is basically their location from the start of the string. For example, the string hello, Hello, have the index location 0, 1, 2, 3, 4, 5. Almost all counting in programming will start with 0 instead of 1. The length of the string is the number of letters in the string. For example, the string hello in greeting has 5 letters, capital H, E, L, L, O. And the length of the string will be used by the method length. For example, greet.length returns 5. That means the length of the string hello is 5. The method include to check if a letter or letters are included in a string. For example, greeting.include he. We return true because we can see hello, Hello, has the location of 0 and 1. The next example, greeting.include ze will return false because the string hello doesn't contain the letter Z and E. We can see the example here, and the outcome of the program is on the right. Greeting length returns 5. Greeting 0 returns H, capital H. Greeting include LLO returns true. Greeting include Z returns false. Greeting square bracket 1, 3 square bracket returns ELL. Those are just a couple of different methods that you can use with strings in Ruby. What I would recommend is going to Google and just typing in like Ruby string methods, and then there should be like huge list of all the different methods that you can use with these strings. We are going to look at all the different things that we can do with numbers. Talking about different types of numbers in Ruby, we're gonna look at some awesome Ruby methods that we can use on our numbers to do with a bunch of different stuff. As mentioned earlier, we have two types of different numbers, integer and float. Integers store things that can be broken up, such as number or minutes in the hour. They can also be used for counting the number of times or loops something has happened. Floats or decimal numbers are often used when precision is a factor, like in scientific measurements, or in many cases when representing percentages. When I want to use numbers in Ruby, it's really easy. You just type out the numbers. So I can type out like 5, for example, and now this is going to get printed out on the screen. You can tell computer to perform any of the 4 basic math operations: additions, subtraction, multiplication, and division by simply writing out the problem like you would normally. Ruby will also respect order of operations. You can group certain expressions using parentheses to encode more complex math operations. If you look in the line 3 here, you also notice that an operation that you might not have seen before, indicated that by the percent sign. This is what is referred to as a modular operator, and is a pretty common operation that is performed in Ruby programs. The modular operator will take the number on the left, divide by the number on the right, and then return the remainder. So if we ask the computer to perform 10 modulo 3, we would get back 1 because 10 divided by 3 is 3 with the remainder of 1. And the outcome can be seen at the bottom here. Now we need to talk a little bit about advanced maths. Aside from all the basic maths operations and the modular operation, Ruby also provides ways of doing more complex and difficult calculations with relatively easy manners. For example, in the program here on the left, we assign the number negative 36.8 to the variable num, and we print the absolute number of the variable num. That will return 36.8. Next, we print the round number of the variable num. That will give the value minus 37. Let's have a look at the lower two lines here. Square root of 144, that will return 12, and logarithm of 0 will return minus infinity. In order to get user input, we need to search and install a package called platform MUI-idle-terminal. The code for accepting user input is actually not that much more complex than the code for printing. In Ruby, we can get user input like this. Puts enter your name. Name equals guest charm. Puts hello and name and how are you. The code above simply prompts the user for information and prints out what they enter in. We can see here on the bottom, enter the name, your name, Andy. Hello Andy, how are you? Now that we have the basics down, play around for a bit and try to change the prompt, or maybe just asking the user for multiple pieces of information and use some of the string functions we talked about in the previous parts to modify it. There's still a lot to learn about getting user input. As of right now, we're only receiving input in the form of strings. As we move forward in the lesson, we'll take a look at how to allow the user to enter numbers and other types of data. This exercise on the left prompts the user to enter 3 different inputs: the color, the plural noun, and the celebrity's name. Then it will print the prompt on the screen. For example, we can have a look at the outcome on the right here. Enter the color, red. Enter plural noun, houses. Enter celebrity, Andy. And then print out roses are red, houses are blue, I love Andy. Now, let's have a look at the array. An array is a container which acts a lot like a variables we've seen so far in this course, except they allow us to store more than one piece of data. Let's have a look at how to create an array in Ruby. We create an array called lucky_numbers, including integer 4, integer 8, string 15, integer 16, integer 23, and decimal number 22.0, with the correspondence indexes 0, 1, 2, 3, 4, and 5. You notice that creating an array is very similar to creating a variable. In this case, we are storing a list of numbers inside the array. Notice how they are separated with commas. In this case, we are populating the array with numbers right off the bat. But a lot of times in the programs, we start with an empty or half-empty array, and we fill up as the program executes. Assume we have the lucky numbers array with the corresponding indexes 0, 1, 2, 3, 4, and 5. The first line of code is to assign the value of 90 into a very first location of lucky numbers. Then we print out the index 0 of the lucky numbers, which is 90. And then we print out the location number 1 of lucky numbers, which is 8. We print out the location minus 1, which is from the right end of the string, which is 22.1. Next, to print out the numbers in square bracket 2 to 4, which is 15, 16, 22, and 42.1. Print out the lucky numbers from 2.4 and return the value 15, 16, and 23. Finally, we use the method length to return the length of the array, which is 6. When you call a method, you are essentially telling Ruby that you want it to stop what it's doing and go execute all the code contained in the method. And once it's done, to come back and keep going on with the normal flow of the program. Let's look at how we can call a method. We start by writing def say hi and open and close bracket, puts hello world and end. To call a method, we simply state the method's name and then directly after place an open and close parenthesis, like say hi, open and close. The open and close parenthesis tells Ruby that you want to actually execute the method. And on the right side here, we can see the outcome of the program, hello. I move on to talk about using returns in Ruby methods. Earlier, we talked about writing methods. Now I want to talk about how methods can give us information back. So when I call the method inside my program, the method will go off. It will execute all this code, but then it can actually give us a piece of information, or in some cases, multiple pieces of information back. And that can be really useful. Look at the cube method here. You essentially take it to the third power. So if I'm going to cube 3, it'd be like 3 raised to third power. So we write a little method that's going to do that for us. So this method will cube a number. It will call the method and execute it in the program and return a value of 27. If statements. Look at 3 examples here. The first example, if it is raining, stay home, else go shopping. Second example, if they have vanilla ice cream, buy me some, else buy me chocolate ice cream. Third example, if it is 3 o'clock, call me, else text me. Basically, if statements allow our programs to respond to the input that they are given. Depending on the state of the data in the program, Ruby will be able to respond to it. So when certain data is certain values, we can do certain things. And when other data is other values, we can do other things. We can even add more logic into this by utilizing our if statement. An if statement is very similar to an if statement. Much like an if statement, it will check a Boolean expression. If that Boolean expression is true, it will allow some code to be executed. Our if statements Boolean expressions are only evaluated. However, after all, if statements or else statements before them have evaluated to false. Let's look at the example here on the left. We have 2 variables, is student and is smart. We check the Booleans of values of those 2 variables. If is student is true, and is smart is true, you are a student and smart. Else if is student is true and not is smart is true, you are a student but not smart. Else you are not a student and not smart. A loop is basically a structure that we can use inside our Ruby programs, which allow us to loop through a particular block of code a specific number of times. So over here, I can actually create a while loop. The first thing I want to do is to actually make a variable index. And I'm going to set it equals to 1. And down here, I actually create while. So the first thing I'm going to do is to type out while, and then what I need to do is just specify a condition. And you always want to make sure that end is off. So I'm going to put an end down here. Now, here's basically how while works and all the code between while and end. So all the code inside here, as we're going to put inside there, is going to get continually executed. The program will print 1, 2, 3, and 4. While checks the condition is still true, it still prints 5, and it increment by 1. So the index is 6. While checks the condition and it is false, it jumps out of the loop and stops the program. The while loops are essentially the same while loop, except while loop checks the Boolean condition first, and then if it's true, it will execute the code in the loop body. Do while loop executes the code in the loop body and then check the Boolean expression. For example here, we check the value 7 into the variable val. If val equals to 7, break and end, that will jump out the loop. Now have a look at the activity 3, guessing game. I'm going to talk about building a guessing game in Ruby. So we actually going to build a little game, and that's basically a game where the user can try to guess a secret word. So we continually prompt the user to guess the secret word. And if they get it right, they get a success message like you've got the word right. And if they get it wrong, they will get the message keep guessing. So they are able to keep guessing what the word is until they get it right. What would be better is if we imposed some sort of a guess limit on them, so they can only guess the word a certain number of times. Otherwise, they lose the game. So let's go ahead and see if we can add that functionality into our program. In order to do that, I'm going to create a couple more variables. The first variable I want to create is going to be called guess count. And guess count is going to basically tell us how many times the user has tried to guess the word. And I'm going to set this equal to 0 because initially the user won't have guessed, so the guess count will just be 0. Now every time the user guesses, I want to increment the guess count. So basically this code means that the user has tried to guess the word. So every time they do that, I want to increment the guess count by 1. And this will add 1 to the guess count. The second variable is going to tell us how many guesses the user can actually take. So it's going to be called guess limit. For example, 3. Finally, I want to create one more variable. And this variable is going to tell us whether or not the user is out of guesses. So I'm just going to say out of guesses is equal to false. In while loop, The first thing I want to do is every time we ask the user to guess the word, I want to make sure that they are not out of guesses. In other words, I want to make sure that they haven't reached the guess limit. So I'm going to use an if statement. To do that inside this while loop, the first thing we are going to do before we do anything else is just say if, and we want to check to make sure that the guess count is less than the guess limit. In other words, if the guess count is less than the guess limit, then we know they have guesses left. We know that they have certain number of guesses left, and then they should be able to keep guessing the word. So if this is true, then I want to allow them to guess the word. Otherwise, in the situation where the guess count is less than the guess limit, then we know that the user is out of guesses. So inside this else statement, I set that out of guesses variable equal to true. We check to see if they are eligible for another guess, and if they aren't, then we are going to say out of guesses is equal to true because they ran out of guesses. At the end, there are two situations. The first situation was when the user ran out of guesses, so they lost the game. And if that's the case, we are just going to pronounce you lose. Otherwise, we'll pronounce you won. And that's the basics of building our guessing game. For loops, let's look at the example here. If we want to print 0 to 5, then the code here for index in 1 to 5, we print out the index. So the answer will be 0, 1, 2, 3, 4, and 5. 6 numbers. Now, how about the next example? 5 dot times to index puts index. In this case, that will print 1, 0, 1, 2, 3, and 4. Print all elements in an array. For example, we have an array lucky underscore nums 4, 8, 15, 16, 23, and 42. And for a lucky number in lucky nums, we print out all the numbers. So that we print all elements in an array. Likewise, the lucky numbers in each we print out all the numbers in an array. Activity 4. Building an exponential function. First, I want to define a power function that has two parameters, base underscore num and power underscore num. Now inside the def, we need to figure out how can we actually do this and how can we take the base number to the power number. And my solution would be to use a for loop. Now, it's important to note that this is only to work for a positive number exponent. So if the power num is a negative number, then this method is actually not going to work. But just for our purposes in this tutorial, let's just assume that we are going to use our positive exponent. So once we multiply result times based on as many times as we need to, then we can just return it. Comments. Comments are generally used to make small notes to yourself or other developers, explain particularly difficult sections of code, or even temporarily move parts of the code altogether. There are two types of comments, single-line comment and multi-line comment. Single-line comment. In a single-line comment, the rules are that anything that comes after the dash on the same line is ignored by Ruby when it executes. For example, dash single line comment. These single line comments are also often used to describe or give more context to a line of code. As a general rule, it's always preferred that you write clear, descriptive code so that comments like this aren't necessary. But every once in a while, a well-placed comment can clear up confusion. Multi-line comments. Multi-line comments have a starting and ending tag, as you can see in the code below. These are generally more convenient for commenting out large blocks of code. Now we are trying to link Ruby to the curriculum. That should be in Unit 3, Software Development, Area of Study 2, an appropriate programming language. There are three things that we mentioned here: key knowledge, key skills, and outcome. In key knowledge, we had three things: digital systems, functions and capabilities of key hardware and software components of digital systems required for processing, storing, and communicating data and information. Data and information, characteristics of data types, types of data structures, approaches to problem solving, features of functional and non-functional solution requirements, constraints and scope, naming conventions for solution elements such as files, functions, methods, and variables, processing features of programming language. Second is key skills. Select and use appropriate design tools to represent solution designs. Use a range of data types and data structures. Develop a software solution using appropriate processing features of programming language. Evaluate the efficiency and effectiveness of software solution to meet the requirements. Outcome. On completion of this unit, the student should be able to interpret teacher-provided solution requirements to design, develop, and evaluate a software solution using a programming language. To achieve this outcome, the student will draw on key knowledge and key skills outlined in Area Study 2. Ruby misconceptions. Most learners have following misconceptions when they learn Ruby. 1. Assigning symbol and comparing symbol. 2. Value in the string and value in an integer. Learners have to use C_CRT or C_integer to convert one value to another. 3. Variable declaration and assignment, syntax and semantics. 4. Loop execution, tracing loop execution correctly. 5. Functions, parameters, scope, and use in design, and call by reference versus call by value. 6. Fail to define methods. 7. Be confused in return statement of methods. 8. Mistakenly apply negative numbers as index position in list. Now we move to discuss about teaching strategies. In order to have effective teaching strategies, we need to answer the following questions. How can we describe explicit programming strategies? How can we support developers in following explicit programming strategies? How do explicit programming strategies help and hinder developers' effectiveness? What strategies do guided and self-guided developers choose to use? How do explicit strategies help and hinder developers' problem solving? To what extent do explicit strategies improve success on debugging and design tasks? The final strategies that I would like to discuss here is the assessment strategies. All assessments at Unit 1, Area Study 2 are school-based. Procedures for assessment of levels of achievement in Unit 1, Area Study 2 are a matter of school decision. For this unit, students are required to demonstrate two outcomes. Is a set of these outcomes encompass the areas of study in the unit. Suitable tasks for assessment in this unit may be selected from the following: a folio of exercises or software solutions, and a written report, a presentation, oral, multimedia, visual, to present findings or software solutions. When teachers allow students to choose between tasks, they must ensure that the tasks they set are of comparable scope and demand. In order to have better understanding on your learning preferences about ICT, could you please answer the following questions at your best knowledge? And based on the answers on the survey, I will have better lesson preparation in the next sessions. Question number 1. Have you ever used or learned any programming language? If yes, what are their names? How confident are you in using these programming languages, ranging from 0, not confident, to 10, very confident? Question 2. Have you ever taught ICT or digital technologies, and what level? Number 3. Would you prefer further sessions to develop advanced Ruby programming skills, or would you prefer learning another programming language? And finally, question 4. Would you prefer further sessions to focus on other aspects of ICT? Thank you very much for listening the tutorial today.